Hello, my name is Keshwani. It's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 285. Page 285, problem number 117, and today is our lesson number 152. Let's take a look at it. We are told that the length of the edging that surrounds circular garden K is half the length of the edging that surrounds circular garden G. And we are simply asked, what is the area? What is the area of garden K? What is the area of garden K? Now the length of the edging of that surrounds a circular garden. Here's your circular garden, and the length of the edging that surrounds the circular garden is just a very awkward way of saying the circumference of the garden. So what this tells us is that the circumference of garden K equals to half the circumference of garden G. Let's see what we can do with it. Let's see what they tell us in the first statement. In the first statement they tell us that the area of G is 25 pi. Alright. So in the first statement they tell us that the area of garden G is 25 pi. Well, if we know the area of the circle, we can figure out the radius of the circle. Look, if we know the area of any circle, we can figure out its radius. We can figure out the radius of garden G. And if we know the radius of the garden G, we can figure out the circumference of the garden G. And once we know the circumference of garden G, we can figure out the circumference of garden K, because circumference of garden K is half the circumference of garden G. Once we know the circumference of garden K, we can figure out the radius of garden K. And once we know the radius of garden K, we can figure out the area of garden K. Which means the first statement by itself is enough. First statement by itself will do the job. Since the first statement by itself is enough, A, D, B, C, E. Since the first statement by itself is enough, the answer cannot be B, C, or E. It will have to be either A or D. The part that we are about to do, we will not be silly enough to actually waste our time in the real exam. But this right now we are doing it for learning purposes, so we're going to actually do it out. So area is 25 pi, which is same as pi r squared. That tells us that r squared must be 25, which means the radius of circular garden G must be 5. It must be 5 meters. Because you see r squared equals 25. If the radius is 5 meters, circumference of garden G must be 2 pi r. Sometimes I use capital letters, sometimes I use small letters, don't get confused. This is the radius. 2 pi r, r g, r subscript g is the radius of garden G. 2 pi r, which we know is 5 meters. So it's 2 times 5 times 5, 2 times pi times 5, so it is 10 pi meters. If the circumference of garden G is 10 pi meters, therefore the circumference of garden K must be 5 pi meters, because it's half. And that of course equals 2 pi times the radius of garden K. Divide both sides by pi and we cross out the pi there. This m is not a variable, it's just meter, which means the radius of garden K must be 5 over 2. 5 over 2 meters. And therefore the area is going to be pi r squared, pi r squared, 5 over 2 squared, and we end up with 25 over 4 times pi meters squared. That's the area of K. But we didn't have to do any of that obviously for the real exam. Let's look at second statement, shall we? The first statement obviously was quite sufficient. Let's see what they tell us in the second statement. In the second statement they tell us that the circumference of garden G is 10 pi. Let's see if that is correct. The edging around G is 10 pi meter long. The edging around G is same as circumference of G, which of course is 2 pi r, radius of G. Again, divide both sides by pi and pi drops out. Now strictly speaking, as soon as I divide both sides by pi, it's no longer equal to circumference of G, you understand? And therefore the radius of G equals 5 meters. And once we know the radius of G, we have the same exact steps, same exact logic, same exact procedure as the one that you just finished, where if you know the circumference of G, we can figure out the circumference of K. Once we figure out the circumference of K, we can figure out the radius of K. And once we have the radius of K, we can figure out the area of K. It's the same exact procedure. So if the first statement by itself was enough, so is the second statement. The answer is D. The answer is D. Alright? I'll see you tomorrow, okay? Bye now.